Our world has told many overlapping stories through physics, geology, chemistry, and biology. Lava flows, plant cells, dinosaurs, and the pyramids, the International Space Station, these objects all give voice to Earth stories. 3.5 billion years ago, on a warmer planet, Earth's first life forms harnessed the chemical properties of carbon and water to sustain, replicate, and complexify themselves. Little by little, life developed near the ocean floor. Critters evolved eyes, instruments of light, perception, and awareness. And from the water, these animals' descendants, early anthropods, migrated toward land. In an evolutionary loop, our cousins, whales, returned to the ocean 50 million years ago. And in a much later chapter, just 700,000 years ago, upright hominids learned to harness fire, writing one of humanity's first technologies. Life stories on Earth are not linear, but rather rhizomatic, branching, feeling, retreating, tumbling, spreading, weaving. Just imagine all the myriad evolutionary paths that lead us here, now, today, in this room, could have taken dramatically different twists and turns. So even with the same basic principles and materials on an early Earth, our planet might have given voice to stories in which life might have been otherwise. Now, multiply that insight across the universe. Our world could be but one chapter in the cosmic book of life, one we're just learning to read. Technologies of perception, space telescopes, microscopes, robots, have let us page through the book of life in greater detail than ever before. And today, we can write new stories by creating alien worlds right here on Earth. These stories are going to help us detect extraterrestrial life. By building speculative planets, we can illuminate the wondrous possible stories just on the next page. Our world building begins by asking what-if questions. What if life emerged on a freezing planet built not of carbon, but of methane-borne polymers threading through hydrocarbon seas? What if all organisms lived on an ocean-covered world? What peculiar limbs and layers would they use to ooze and amble? What if the fusion of technological tools with nature merged mind and matter? What chapters, what paths not taken here on Earth are spoken on other planets? So for the past 2 years, I've been collaborating with planetary scientists, astrobiologists, artists, and philosophers to scrawl new chapters into this book of life. Pairing renowned scientists at places like MIT and NASA with designers and speculative fiction writers, we've dreamed up planets that are strange, yet familiar. These worlds are grounded in advanced scientific modeling, planetary simulations, and evolutionary projections. They combine fields of astrobiology, artificial intelligence, physics, and chemistry to construct strange life. These new worlds have become beacons to point us toward that hypothetical alien life. These worlds bend time. They beckon to new possibilities. They even help us retrace pathways of our life on Earth. So welcome all to Proxima Kósmos, a solar system that is similar but not identical to our own. It is home to 9 speculative worlds. Proxima, from Latin, means next. It also means near. The worlds in Proxima Kósmos are extraterrestrial, yet perhaps they are next worlds we are set to discover. Minor tweaks in the levers of life have yielded new stanzas in life's story. And tonight, you'll encounter 3 of these worlds. A sessile slime on a Saturnine planet, an unbloomed now on an erstwhile Earth, a sentient system across a procreant planet. Each world was imagined by creators in science, fiction, and design. Each world is a glimpse of what it means to write in the book of life with new scientific, cutting-edge, and narrative tools. Each world harbors life in strange registers, yet unspoken. Choose your own adventure. On Earth, we can learn a lot about just how persistent life is. Think of the tardigrades that we sent to outer space and survived, to the microbial colonies and weird organisms that flourish in hydrothermal vents near the ocean floor. Places we once thought were completely uninhabitable up to just a few decades ago, we know now are teeming with life. Acro, from Greek, means end or extreme. On Acroterra, we wanted to explore a world completely inhospitable to humans, but not, perhaps, to other forms of life. Acroterra is a faint jade world, veiled in a dense atmosphere. Its gauzy gases diffuse the star's light, casting the surface in a dim, protecting glow. Temperatures here drop to hundreds of degrees below zero. We worked with Dr. Penny Boston, who's a speleologist, a cave explorer, who leads astrobiology at NASA. She imagined that the planet's rivers of liquid methane flowed and then trickled into the caves of the planet. Acroterra's life is subterranean, feeding on nutrients deposited by methane floods. They are syncytia. Like slime molds, they embody one large cell with many, many nuclei. Acroterra's life forms spread across the cave, shaping it and shaping itself, evolving a complex, collective consciousness. The world evokes possibilities of life on a not too far off place, such as Titan, moon of Saturn, whose atmosphere is also rich in diverse hydrocarbons. So now, please help me in welcoming Shane Griffin, visual designer at Grif Studio, who created the slimy syncytia of Acroterra.
Thank you, Claire. My role in Proxima Kósmos was to develop vibrant liveliness in Acroterra's alien caves. I wanted to turn silicon-based slime molds into something you could see, but also feel, sensing their sensing. When I began to work on Acroterra, I tried to imagine life that is not only unfamiliar to human habitability, we wouldn't survive for a second on Acroterra, but alien in its very chemistry. Nourished through methane, not water, not individual, but vast. Single-cell organisms collectively climbing, sporing, sliming. My challenge was this: how could I design something simultaneously biological, geological, and architectural? For me, the answers to that question, they live in algorithms, a protocol for solving puzzles. Dr. Boston's life forms, they needed to evolve and adapt collectively, working with the existing structure of the icy cave. So I began to ask, how do I breathe computation into design? How do I embed a feeling of organic liveliness using computer programming? How do I represent alien fungal-like organisms would think together? How would they evolve together and become one? How do I blend the algorithms of alien biology with those of earthly artificial intelligence? To answer that, I looked first to one of Earth's strangest organisms, the slime mold. Slime molds are humble but extraordinary. Amber has preserved slime molds, and they've been around for billions of years on Earth. They have no brain, they have no neurons, and yet they solve mazes. Slime moles not only find the shortest path to nutrients, but they mark dead ends, and they remember pathways of the past. Slime moles build networks more efficiently than humans build cities. In fact, scientists once compared slime mole networks to the Tokyo subway system, and the slime's design was nearly identical. Velcro was inspired by the sticky buns in the forest, and that's biomimicry. But what's happening in the caves of Acroterra is the inverse. It's artificial mimicry. I infused AI algorithms into the life form's logic. On Earth, slime moles are small and overlooked, but on Acroterra, they become the protagonist. My studio started by sculpting the cave. To start with some sketches, we used pen on paper to block things out. We wanted to give the life forms a variegated to explore its environment and solve these problems within it. Now, the icy cave was ripe for life. In my practice, I work with generative algorithms, systems that model how natural patterns emerge from simple mathematical rules. We explored several different styles of this. Diffusion-limited aggregation, where the particles branch and spread into open space. Shortest path algorithms, which grow toward a goal along the most efficient route. Space colonization and reaction diffusion models, which mimic how veins or fungi fill the available space. Together, they allowed life to grow from pattern into structure, to become architecture. For Acroterra's life forms, I designed rules that mimic these same principles of growth: branching, recursion, accreting patterns. The idea was not to sculpt a character, but to let these rules unfold. They echo how slime moles probe their environment, how vines test for light, how mycelial networks spread underground. And what emerged were not creatures, but processes, living systems in motion. When we build to the end of the world, we have to see the horizon. It's building alien rocks. It's building alien water. It's bioluminescence. Everything we take for granted on Earth, we have to unpeel and rethink. In 3D, nothing is predetermined. It's not like shooting a movie where the textures, the colors, and the lights are given. In CG, you have to think about everything: position, light, fog, the atmospherics, and how all of these elements interact on an alien world. First, we focused on how slime emerges. Here, you'll see the slime pulsing, branching. It's not a brain firing, but a thought in another register. These systems, they collide with the environment. It's dynamic growth that moves with the environment that we craft. Life forms moving with purpose and intelligence. And what is special about this project, that all of these life forms, they could exist and may exist, but we still had to leave room for creative license. On Earth, pinks are relatively uncommon. Nature rarely makes them, apart from flowers. So we chose shades of fuchsia, violet, magenta that felt alien. We also imagined a secondary three-dimensional structure. We wanted the slime to feel aware of space while also working together to reach a common goal, using space colonization algorithms to grow from slime to structure. We gave these life forms a target-oriented puzzle. Reach the top of the cave in the most efficient way possible. The result is simulated, microscopic, and mathematical life. Consciousness distributed through ooze and fiber. Collective, decentralized, alive. Thought written into slime. But slime on Acroterra is never isolated. It's fused with its terrain. The caves are not a backdrop, they're a body. Over centuries, Slime becomes the cave. Its fibers weave into the massive, massive columns. Its pulses illuminate the ice. Its growth reshapes caverns into chambers and passageways. On one side, light absorbs from the star and is then stored in the ice, which glows from within. But on the other, hot pink veins surge with energy, a metabolism utterly alien. It's disgusting. It's juicy. It's gross, in just the right way. And over time, it becomes indistinguishable from the stone itself. This is the provocation of Acroterra. On Earth, we separate life and landscape, organism from environment. But here, that line collapses. What if intelligence doesn't need a nervous system? What if it sees through the ice and stone and writes itself into the walls of the caverns? What if the alien is not other, but the environment itself, slowly awakening? Slime is organism. The slime is the architect. The slime is the cave. For me, designing Acroterra was never merely about illustrating an alien. It was about letting strangeness emerge. It was about collaboration. Dr. Boston's science, my generative AI systems, Earth's analogs, slime molds, caves, Titan's rivers. Together, they suggest that life may be stranger than we can ever imagine. Not creature, but architecture. Not character, but process. That balance, speculative yet plausible, is what Acroterra embodies. Thank you.
Thank you, Shane. Next planet. On Magicos, lights glimmer and pulse across the surface, much like on Earth. It is a possible future for our own story, one where biology and technology have completely merged, and a world consists not of many, but a single planetary intelligence. Please welcome Estelle Janin, astrophysicist at Arizona State University.
Behold the surface of Magicos. Everything around you unfolds in woven, intricate structures, a layered tapestry of networks and interconnected objects, shaping the world in heartfelt complexity. You can almost feel the planet pulse. Matter is shifting, moving, building. The entire planet is thinking. Magicos has grown itself layer by layer, accumulating existence in a unique way and storing echoes of its past in its very structure. This world remembers itself, selects upon itself, and in doing so, it evolves ever greater complexity. Astrobiologist Sarah Walker and I, through a new framework called assembly theory, study the relationship between life and complexity. Think of the universe as constantly exploring the space of possibilities. Not everything that can exist does exist. Choices have to be made. If it wants to build upwards in complexity, the universe needs to commit to specific trajectories. It must choose depth over breadth. But the more complex an object is, the more steps are needed to construct it. If it wants this object to persist, the universe must be able to make many copies of it. Therefore, it needs to remember how to build this object. Committing to build some objects rather than others, and retaining the memory of how to build increasingly complex objects is what we call selection. And selection is exactly what life does. It produces complex objects in abundance. In other words, life is the best way the universe has found to explore and discover itself. You and everything around you are the product of selection and evolution. Magikos is the perfect example of an object so complex, so deep in time, that it is ripe for a new phase transition. There's no single intelligence here, no centralized ruler, no ensemble of artificial machines controlling life. Instead, the planet itself is alive. This has radical implications. As I said, producing complex objects in abundance is what life does best. Molecules replicate, cells divide, organisms reproduce. Now, an entire world is about to do the same. One intelligent planet is ready to become two. The making of an intelligent planet is now robustly encoded in the universe, such that baby Magikos can be born, and itself start growing, adapting, and evolving. Intelligence at the planetary scale has reproduced. In our lab, we're not only theorizing planetary intelligence, we are testing it. Using an algorithmic program called Assembly Calculator, coupled with planetary simulation models, we study how molecular objects assemble themselves into increasingly complex structures. This allows us to investigate the boundaries of what makes a system alive. We explore how memory is encoded in matter, and whether self-replicating planetary systems are an inevitable result of evolution at scale. Applying assembly theory to an imagined exoplanet, Magikos, means that we have to understand how the complexity generated at a planetary scale by a biosphere translates into our observational window for these remote worlds, their atmospheres. By analyzing the chemical space of planetary atmospheres through our telescopes and generative models, we hope to answer one of the deepest questions in astrobiology. What are the universal signatures of life and intelligence, regardless of what form they take? So let me ask you, if we had never encountered Earth before and looked at our own planet from a distance, how would we recognize intelligence? Would we assume life was confined to individual organisms with signatures that would exactly resemble those of our own planet? Or would we see the entire biosphere as one system, shaping itself, responding, adapting, the result of so many billions of years of evolution that it would undoubtedly look incredibly different elsewhere? Indeed, if we are ever to detect alien life, we must be able to identify universal signatures of evolution and selection and make the strange look familiar. This is the motive that drives Magikos. It asks us to reconceptualize life and intelligence, not as properties limited to individual minds, but as complexities that emerge and grow across scales, systems, and agents. Complexity is not just a product of biology. It is a consequence of the universe exploring and building itself. Given the right conditions, intelligence will emerge and it will spread. If Magikos is alive, then it is not the only one. There may be other planets that have crossed the same threshold. It may be a template for intelligent life detection. Magikos and baby Magikos force us to rethink life, not just as something that happens on planets, but as something that planets become. They also challenge our ideas about evolution and the trajectory of our own planet. Magicos and Baby Magicos ask us to imagine a future where intelligence is not confined to human minds, where knowledge is not just stored in books, but where entire worlds think. As humans, we often see ourselves as the architects of intelligence. But what if we are simply one phase in our planet's own evolution? Could Earth itself be standing on the edge of a beautiful transformation? A world that remembers, a world that learns, a world that one day reaches beyond itself. Thank you.
Thank you, Estelle. Xenoterra is not a future of earthly life, but a possible past and alternate present. The planet hosts life forms that follow other evolutionary pathways that might have been on Earth. Xenoterra is a probe into the universal laws of evolution, the repeated motifs in the Book of Life. 4-time Hugo Award winner, the science fiction author Mary Robinette Kowal, worked with scientific models to imagine what it might feel like to encounter other worlds, not as data, but as lived experiences. Tonight, she's going to read from her story, Rewinding Evolution.
Xenoterra is an alternate Earth, a place where evolution zigged instead of zagged. Xenoterra is a trilogy of evolutionary experiences. Aponorista Terra, or early Earth, where the first multicellular life swims through pink oceans. Xenoterra, strange Earth, where creatures arrive at familiar functions by unfamiliar roots. And Necrosterra, dead Earth, a world of collapse and silence. My task was to imagine what it might feel like to encounter these worlds not as abstract models, but as places where humans might stand and listen for signs of life. And that's the story that I'll share with you through 2 excerpts now. Rewinding Evolution, Chapter 1. When you were so far away from home that distance was measured in light years instead of kilometers, the word homesickness lost all meaning. Tatiana sat in the comm seat on the bridge of the Ambassador, waiting to turn the system on, and wished that her mother could witness this historic moment. It would have given her hope. She glanced over her shoulder at the small team behind her. Nico, their mission commander, still hadn't removed the beard of his cold sleep and had his long hair tucked behind his ears. When they'd left Earth 40 years ago, it had been military short, like most of the male astronauts at NASA. Now he had his arms crossed over his chest, and even in a light blue flight suit, looked like a Greek demigod. He looked from her to Sandra and Christian, and spoke in Esperanto, which they had been using since they had begun training for the mission. Everyone ready? God, yes! Christian's Esperanto was practically shouted with excitement. He had set up 3 cameras on the bridge in addition to the ones that the United Nations had requested. I've been waiting for this my whole life. We all have. Tatiana had been 4 years old when SETI had first picked up signals from the Proxima Kósmos system. She turned back to the comms array, which looked like the same gray and chrome console she had used in all their simulations. Her Esperanto had become as natural and fluent as her first and second languages. I want you to all respect how much willpower it took to not power up this system as soon as I was awake. Thank you for following the checklist. Nico's voice was dryly amused. Proceed with activating the comms array. Switches clicked under her fingers. Screens alit with meters and channel indicators glowing against a dark background. They had been sent here to make first contact with an alien planet, or more accurately, second contact, since a probe had been launched ahead of them to lay the groundwork for their arrival in peace. That was part of why it was a small ship with only 4 people. What better way to say we're not a threat than to be small and unassuming? The familiar movements from so many simulations at home grounded her. But when she reached for the final switch, shivers chased themselves over her skin. They were about to hear new signals from Proxima Kósmos instead of ones that had crossed light years to Earth. Her stomach had tightened, anticipating wonder without knowing the shape of it. They might hear the same wash of broadcast media they had received, or, in the idealized version of the plan, the probe might have worked, packed as it had been with materials to learn a single human language, Esperanto. There was an outside possibility that they might hear a greeting tailored specifically for them. She clicked the switch. Static played over the speakers. Her breath stopped. There should have been a cacophony of signals. Frowning, Tatiana checked the antenna, which was at the right orientation, and adjusted the frequencies she was scanning. She had added communications as a skill set to round out the crew and as an expansion to her actual skill set. Give her a computer and sufficient processing power, and she could create simulations of anything, which was supposed to help find a working language with the Xeno people. The hiss continued, broken by pops and crackles as she scanned through the entire range available to her. Behind her, Christian shifted his weight and leaned over the back of her chair. Are the antennas pointed at them? First thing I checked. But she switched from the forward antennas to the rear ones to look for signals from mission control to confirm that the system was working. Immediately, a voice filled the air. This is the broadcast channel for the international mission to the Proxima Kósmos system. We anticipate that your 40-year transit should be at an end and that you will be in position soon. This recording will repeat on a loop with monthly updates from the home planet. She turned it off. I'll record that later. Thank you, Nico said. Good to know that the plan is still back in place at home, at any rate. Tatiana switched back to the forward array. She was missing something. Everything looked active, and there were no telltales of any sort of warning of any system failure. The only failure was likely to be user error. Tatiana bit the inside of her lower lip and picked up the checklist. Will someone read these out as I work through from the top? Of course. Nico reached past her to take the list. He didn't have a hint of reprimand in his voice, but she layered that all in for herself. The planet PK Chad had been broadcasting music and voices and what were recognizably entertainment programs for decades across multiple channels in the same way that the early days of Earth broadcasts had been beaming television and radio to the stars. Multiple languages, multiple different styles of music. There ought to be something to pick up. The checklist was not long. The static continued to play over the speaker. When she finished, she spun her chair to look at the 3 people with whom she'd made the long trip between the stars. I'm sorry, I don't know what the problem is. Visible distress had reshaped Christian's face with worried lines that did not belong there. He laughed too loud and looked at Nico. We're in the right system, aren't we? Yeah. He set the checklist down at Titania's station. 3 planets orbiting in the same orbit around a K-class star. We're in the right place. Let's break out the troubleshooting binders and start working the problem. Christian, you're with Tatiana on comms. That made sense. It wasn't a reflection on her skills. Christian was the engineer for the expedition, and he was the one most likely to be able to spot a mechanical failure. Tatiana hadn't really ever hoped before that something was broken, because the remaining choice was that she had done something stupid. And if that wasn't the problem, then the planet they had given up their lives on Earth to contact was silent. They had practiced simulations for a hostile response to their arrival in the system. They had not practiced for silence. Now let me take you 5 chapters forward to our first glimpse of Xenoterra. Wind rustles through a forest of twisting plants that are not trees but occupy that space, with densely twisting trunks that reach for the sky like fingers. At the top, they hold massive, delicate bubbles to create a translucent canopy. In between trunks, sheltered from the wind, smaller plants twine around the bases in symbiotic harmony. They snake up the sides of the trunks toward the pale yellow sky. The wind through their reaching branches is not the only sound beneath the orange sun. This is a world of voice. Sound is everywhere. Little peeping creatures creep along the spiraling trunks of the trees, calling to each other as they burrow into the dark hollow within the trunks. Their voices blend with the babble of water as it rushes around bends, skipping over rocks with a wild abandon until it tips over the last remnants of a crater to tumble down a sloping run into a pale pink pool. Wheeling over the pool, spherical creatures ride the updrafts of the warm, humid air. They sing a buzzing, humming, shared song that creates a network of information about thermals and turbulence. They have a multitude of buzzing wings built for hovering, but they can be folded quickly to dive. Their translucent bodies shine amber in the orange light of the sun. These creatures sense the world across their skin in layers of reds and yellows and ultraviolets. They catch the quick movements of creatures below them. A long, pale, white creature floats in the water, with trailing tendrils at both ends like a scarf. It senses a slip of food and dives through the water, undulating as it gives chase. Neither has dedicated visual sense organs, but both create a map by the pressure waves against their bodies, building a comprehensive 3-dimensional awareness of space. The morsel it pursues squirts through the water into the deep blue until it finds an absence of pressure in front of it, in between the ruddy stones. It dives for the cave, disappearing into it. The pursuer feels it vanish. It reaches for the cave and can tell from the pressure against its tendrils that it cannot fit. Pushing off from the silty bottom of the pond, it rises and floats below the surface of the water. It waits, trying not to move, to keep its pressure waves small and unassuming and safe. The water around it stills again. Beneath the flock, a thick worm has explored too far past the protections of the forest. It trails heavy pendants that look like legs at first glance, but they sense and taste. These appendages taste the air for predators. The flock is too far above to sense. The thick worm toddles out of the shade into the warmth on the pink, sandy slope by the river, shifting its body in a clumsy dance as it looks for food of its own. A shadow covers it. Then an amber orb envelops its body, snatching the thick worm from the ground. It shrieks a song of terror and lashes back and forth, looking for escape. It does not find it. The flying creature carries its prize back up to the flock, where they touch their amber orbs one to the next, merging briefly to share the meal among each other as a gift to the community. Their song changes to a burbling harmony of connection and satisfaction. Below them, the planet wheels on, bearing tumultuous, chattering life. Each piece is a link in a chain of interconnected wonder. Viewed individually, they are a curiosity. Together, they sing.
Mary Robinette. Okay, so now I'm going to ask for your participation. To find life beyond Earth, we have to imagine alien ways of being. Place your hands on your chest. Take in a long, deep breath. Hold it and count to 4. Feel your heart pump life through your body. Breathe out and count to 6. Feel the blood flowing back to your heart, thirsty and seeking. Each breath of life is a mere sliver of a blip, of a fraction of cosmic time. Keep breathing. And as you do, imagine each heartbeat transports you hundreds of millions of years into the past. You morph. You shrink. You turn green. Your respiration transforms into photosynthesis. Your lungs harden into something like plant matter, more rigid, more structured. You absorb the energy of an earlier, dimmer, lemon-hued sun. You weave about in a warm, ancient ocean with innumerable companions, Earth's primordial life forms, cyanobacteria. Some 2.5 billion years ago, our planet was a different world. Carbon dioxide clotted the atmosphere, trapping in heat. On a world much, much warmer than it is today, life that lived without oxygen dominated Earth's swirling rose-pink oceans. But then, cyanobacteria made an evolutionary leap. They harnessed a green pigment called chlorophyll. This new breed of bacteria began to convert sunlight into energy. Those microscopic, single-celled organisms transformed the planet. They made an oxygen-rich atmosphere that life as we know it has relied on for billions and billions of years. Cyanobacteria breathed life into our planet. They dyed Earth's rosy oceans a cerulean blue. They remade our world made you. The arrow of time that links those ancient organisms to you today is just one possible evolutionary path of our planet. Since the 1960s, we've sent humans to the moon to collect lunar soil. We've landed rovers on Mars, sent spacecrafts around Venus, and photographed moons at the edges of our solar system. Today, we use new technologies and telescopes to study exoplanets far, far away. And yet the existence of life beyond this planet remains a deep and abiding mystery. So to better search for what's out there, we can start by building alien life right here. Thank you.
Claire, a huge thank you to you and to your collaborators, to our musicians this evening, for really helping us to imagine a world beyond this one that we inhabit today. Everyone, I'm Eric Scheiner, and I have the great honor of serving as president here at Powerhouse Arts, and it is a huge honor to welcome all of you here today for this performance and for what is to follow. I thought it might be helpful for you to know a little bit about this rather vast building that we inhabit today. And I want to thank the Berggruen Institute for collaborating with us on temporarily transforming this 170,000 square foot factory of art and ideas into a spaceship that might take us to other worlds. And within this ship, where we happen to inhabit the very belly right now, in the middle of what was once a vast turbine hall that literally powered Brooklyn through sending energy to the trolley car system back in the first decade of the 20th century, and later the subway system. That today we take this former shell of a building and have turned it into a place of making, a place of imagining. And our 7 workshops working in media as far-flung as metal and wood and textiles and printmaking and ceramics and many others welcome artists into this ship to start to build and to make and to imagine and to innovate, and really to help all of us to imagine alternate realities. And we're really happy to share it with all of you here today. I hope that you are frequent visitors, and as a very new organization, just 2 years old, we are unfolding in what we hope is some rather interesting ways. Right now, we are playing host to our brand new Powerhouse International Performing Arts Festival that will run until mid-December. Our theme for the festival are two things, radicality and globalism, things that we feel are more necessary today than probably ever before. Next year, we start to welcome exhibitions into our mix, and we will welcome you into virtual worlds, into worlds that are created through the aggregate, and also queer worlds, just a little bit of foreshadowing of things to come. But we hope that this site becomes a welcoming place for all of you to think about creative expression and how it folds into your own life and how you can utilize it to journey into worlds far beyond. I now invite you all to join us on our third deck, I should say, usually I would say floor, where we're going to partake in some very experimental food, some experimental sound, and I'm very happy to welcome incredible friend and artist Saya Woolfolk, who's here with us today, who is going to lead a workshop based on another world and ecosystem that happens to be in our very backyard, the Gowanus Canal. Obviously, those of you that know Gowanus know that the Gowanus Canal is the most toxic body of water in this country and is also a Superfund site of the EPA. It has been cleaned, filtered, reconfigured for the past 8 years. It now resembles water. It is home to fish and to geese and many other forms of wildlife that have come back, and is certainly much better than the black mayonnaise substance that it once was. But Saya is going to teach folks a little bit about how life subsists in not always the most welcoming of environments. We hope that you always view Powerhouse Arts as a welcoming environment, and we'll hope to see you back very soon. Thank you again, all.
Thank you so much to our presenters and also the musicians who really made this very special. Thank you.